this is the question from August 2021. They have asked you that what is the difference between the sequential and the combinational circuit. So this is the question of digital electronics. Okay. So digital electronics, if we'll have sequential circuits are just like flip-flop. Okay. As you know, it's based on sequence key. Like if I told you about the SR flip-flop, the diagram for the SR flip-flop is like this. Here output is connected towards the input and this one is this one. So the output of the one NAND gate will goes towards the input of the second NAND gate, right? Similarly, output of the third NAND gate will become the input of the fourth NAND gate, correct? So it is in the sequence now. It will follow the sequence. Then again we can have some, if we'll use for JK flip-flop or master slave JK flip-flop, then also in that case कि एक के output दूसरे के input बन रही है. So this is the sequential circuit. So best example for that is flip-flop, or we can say register. Now the combinational circuit एक हमने input दिया है and according to that we'll get some output, right? So what example for combinational circuits is like adder, right? Multiplexer, demultiplexer, or subtractor. Adder may you remember what we'll have? We'll give two inputs. Suppose if we'll have half adder A, B, and then accordingly we'll have output sum and carry. यही था. तो sum और carry किसी की next input तो नहीं था, right? So that is combinational. If it is in sequence, then it will known as sequential circuit. If it is not in sequence, then it is the combinational circuit. In the flip-flop, I told you flip-flop is a device which is used to store the element. So in this case, memory element is present. Okay. And in this case, in the combinational circuit, we don't have any memory element. Got it? In the flip-flop, as you know, clock signal, we always provide the clock signal towards the flip-flop, correct? So clock signal is there, correct? And remember, do we provide a clock signal in the adder or in the multiplexer? No. So no clock signal is required. Understood? In this case, output depends on the input and the past output. In this case, output is not depending on the present input. Got it? So these are the basic three difference which they can ask from you. Noted down. Next one is the registers, or we can call it as a shift register. So shift register is basically divided into four categories. One is SISO, okay. Another one is SIPO. Another one is PISO. Another one is PIPO. What is this SIO? See, basically I stands for input. Okay. O stands for output. S stands for serial, and P stands for parallel. So SISO is serial in, serial out. Okay. SIPO is serial in. Tell me. PO means parallel out. PISO means parallel in or serial out. PIPO means parallel in, parallel out. Understood? Now I am giving you one example. Serial in, serial out. Suppose you are going for a movie and there is a long queue over there. Okay, so there is an entry of one by one, like one person buy a ticket, then it allows to go move in. Okay, so one person is moving in and one person is moving out. So this is the case of serial in serial out. ठीक है, एक गया अंदर और एक बाहर गया, एक अंदर गया. Serial ins means one by one it is going inside and one by one it is going outside. Clear? Now next thing, serial in parallel out. अब जैसे we'll have only one door in the input, but if we'll have four door in the output, suppose, तो एक एक करके one by one it is going inside and it is going parallelly outside. तो चार जने, 4 person they can move outside parallelly, right? सीरियल इन मीन्स कि वन बाय वन करके एक एक जाएगा. ठीक है, चार दरवाजे हैं और चारों दरवाजों से एक एक बंदा, मतलब साथ के साथ में बाहर आ जाएंगे. ओके, what is now parallel in serial out? Now you tell me. Okay, now see how can we design this one. Suppose I am designing SISO. SISO means serial in serial out. So I am taking the 4 flip-flop. You can take 3, but generally the thing is we'll generally take the 4 flip-flop. Yeah, so this is flip-flop 1, this is flip-flop 2, this is flip-flop 3, this is flip-flop 4. All are triggered with the same clock. This is clock. All are negative edge triggered or positive edge triggered, that depends on you. You can take any of the thing. Okay, I'm taking positive edge triggered. I told you na, if there is a circle over there then it is a negative edge triggered. If there is no circle over there then it is a positive edge triggered. Correct? Now in this we'll have D1 for data, Q1 for outside, D2, Q2, right? D3, Q3, D4, Q4. Correct? So data is entering serial in, data we are getting serial out. These are connected with each other. Okay, so this is known as serial in serial out shift register. Clear? So now it is shifting the data left or right. It is shifting data right, so we can say it is a right shift register. If it is shifting the data left then it is known as left. So in that case everything will be opposite बनाएंगे, flip flop उल्टा बनाएंगे. Like Q यहाँ होगा, D यहाँ होगा. Okay, Q यहाँ, D यहाँ, Q यहाँ, D यहाँ. That will be completely opposite. Understood? Now based on this we need to make the truth table. Suppose we want to enter the data 1010. Okay, so if we enter the data 1010, we'll have how many outputs? Q1, Q2, Q3, Q4, right? We'll have 4 output, Q1, Q2, Q3, Q4. So here it would be clock pulse. So if we enter the data, that is I enter the data 1010, सबसे पहले we'll start with this one. We enter 0. Yeah, like suppose कि मैंने यहाँ पे 0 दिया D1 में, तो D1 में 0 दिया, what would be the output? डेटा है D flip flop we are using, तो D flip flop में जो input हम देते हैं will get the same output, right? ये 0 दिया है तो output will be 0 only. यहाँ पे अभी हमने कुछ भी नहीं दिया, so these are blank. So Q1 is 0, यहाँ पे कुछ भी नहीं है, ऐसे डिनोट कर. फिर नेक्स्ट साइकिल में लाइक दिस इज क्लॉक 1, क्लॉक 2 में अब मैं दूसरे डाटा को दूसरे बंदे को भेजूंगी, है ना. पहले एक बंदे को भेज दिया 0 को, फिर अब मैं किसको भेजूंगी, 1 को, 1 को भेज दिया। जैसे ही आई शिफ्टेड 1, तो मैंने यहाँ पे 1 कर दिया, तो Q1 क्या हो जाएगा, 1। Q1 में पहले क्या था, 0, उसने आगे शिफ्ट कर दिया, तो Q2 भी क्या हो जाएगा, 0। करेक्ट। ऐसे सोचो कि तुम भेज रहे हो, एक एक करके बंदे को भेज रहे हो, यहाँ पे आ गया, अब कोई नया बंदा आ गया, ये आगे शिफ्ट हो गया। हॉस्पिटल्स में होता है ना, लाइक पहले यहाँ पे जाना है, फिर यहाँ पे जाना है, फिर यहाँ पे जाना है, 1 by 1 दे आर सेंडिंग द पर्सन, सो अनदर पर्सन 1 केम, 0 जो यहाँ पे बैठा हुआ था, ही शिफ्टेड टू द नेक्स्ट वन, so the output of Q2 is 0 and Q1 is 1। क्लियर। यहाँ पे अब थर्ड क्लॉक साइकिल में थर्ड नंबर पे किसको भेजोगे, 0 आएगा, तो ये दोनों आगे शिफ्ट हो जाएंगे, राइट, 1 0। फिर देन किसको भेजोगे, हाँ 1 0, तो ये तीनों आगे शिफ्ट। तो नाउ हियर डेटा इज सॉर्टेड। क्लियर। अब सपोज मैंने एक और साइकिल चला दी, फिफ्थ साइकिल, यहाँ तक तो डेटा लोड हो गया। फिफ्थ साइकिल में अब क्या होगा, इस बंदे का काम हो गया, ये डॉक्टर से मीट कर गया, तो अब ये क्या चला जाएगा, अपने घर चला जाएगा, राइट। नेक्स्ट साइकिल में ये अपने घर चला गया, तो ये आगे शिफ्ट होते जाएंगे, सो इट वुड बी 1 0 1, वो अपने घर चला गया, अब यहाँ पे ब्लैंक हो गया। क्लियर। नोट डाउन दिस थिंग। नेक्स्ट वन इज सीरियल इन पैरेलल आउट। ठीक है, अगेन यूज 4 फ्लिप फ्लॉप, 4 फ्लिप फ्लॉप बोल लो। दिस इज फ्लिप फ्लॉप 1, फ्लिप फ्लॉप 2, फ्लिप फ्लॉप 3, फ्लिप फ्लॉप 4। ओके, so we are providing the clock pulse, पॉजिटिव एज ही दे रहे हैं, that is CLK, input is D1 Q1 D2 Q2 D4 Q4, right? But input is we are giving like this, serial in, right? To connect it, if it is serial in, connect this one output Q1 with D2, Q2 with D3, Q3 with D4. Then we need to get parallel out. So parallel out is how much, Q1 Q2 Q3 Q4। हम डेटा कैसे दे रहे हैं, अंदर एक एक करके, एक मैंने 1 को यहाँ भेजा, फिर आया 1 0 1 0, ओके, बट आउटपुट सारे एक साथ आएंगे, बंदा एक एक करके अंदर जा रहा है, बाहर सारे एक साथ आएंगे, लाइक मूवी हॉल में होता है कि एक एक करके अंदर जा रहे हैं, ठीक है, और जब मूवी खत्म हो जाती है तो बाहर सारे एक साथ आते हैं, 3 4 गेट हो जाते हैं, जैसे सारे गेट से अलग अलग बाहर आ जाते हैं। गॉट इट। नेक्स्ट वी नीड टू ड्रॉ द ट्रूथ टेबल। आउटपुट 4 है, तो Q1 Q2 Q3 Q4, क्लॉक 1, क्लॉक साइकिल मतलब 1 2 3 4। सपोज अगेन वी वांट टू एंटर द डाटा 1 0 1 0, तो पहले कुछ भी नहीं था, फर्स्ट यू एंटर 0, बाकी सब ब्लैंक, देन यू एंटर 1, तो 0 आगे शिफ्ट हो जाएगा, देन ब्लैंक, देन यू एंटर 0, 1 और 0 आगे शिफ्ट हो जाएंगे, देन 1 0 1 0, हियर डाटा इज लोडेड, और ये एक साथ बाहर आ जाएंगे, ओके, everything. So this is the case. Note it down. Now see this question. This is from August 2021. Differentiate between sequential and combinational. That I told you already, right? Now next they are asking, consider a serial input data. Data they have given 1, 2, 3, 4. I think it's 8-bit fed to a 4-bit shift register circuit from LSB. So data we are entering from the left side, right? what will be the output for CISO operation after the 6th clock pulse? So they are asking for the 6th clock pulse. How many clock pulses are required to shift MSB bit to the output? So we have to draw it. Like suppose मैं छोटा छोटा draw कर रही हूँ. If it's a 8 bit, we need to draw 8 flip flop. Okay. 1, 2, 3, 4, 5, 6, 7, 8. And in this case, it is D1, D2, D3, D4, D5, D6, 7, D8, right? So output is Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8, right? Then we need to provide the clock pulse. A common clock pulse provide कर देना like this. Understood? I'm drawing roughly. ठीक है? Now we need to draw about the main. They are asking for the truth table. So how many are the outputs? 8 outputs. So we need to draw for 8. Like suppose it is Q1, Q2, Q3, Q4, Q5, Q6, Q7, Q8 or a clock pulse. Correct? अब now if we are talking about the first clock pulse, so देखो data they have given us 1110 1110 110 110, right? नहीं 110 exit. तो as they already mentioned, हमें डाटा कहाँ से भेजना है? Left LSB. LSB means least significant bit. Least significant bit is what? ये है. तो जो फर्स्ट वाली होती है दैट इज MSB, ठीक है. एंड जो लास्ट वाली होती है दैट इज LSB. जनरली हम LSB से ही भेजते हैं, लास्ट से भेजते हैं, बट दिस मेंशन आल्सो दैट वी नीड टू स्टार्ट इट फ्रॉम LSB. ओके. तो पहले किसको भेजेंगे? 0 को. तो 0 यहाँ पे आ जाएगा, राइट? बाकी सब में कुछ भी नहीं. देन किसको भेजेंगे? 1. तो 1 यहाँ पे आ जाएगा. 0 नीड टू बी शिफ्टेड. देन बाकी सब में ब्लैंक, लाइक मैं ऐसे लिख रही हूँ. देन अगेन देन 1 की बारी आएगी. 1 0, बाकी सब में ब्लैंक. देन किसको भेजेंगे? 0 को. देन ये शिफ्ट हो जाएंगे, राइट? देन फिर से 0 को. 0 1 1 को. फिर किसको भेजेंगे? 1 को. तो कितना आ जाएगा? 0 0 1. फिर 1 को भेजेंगे. 0, यही है ना? देन 1 को भेजेंगे. तो 1 1 1 1 0 आ गया. देखो पूरा डेटा 8 क्लॉक साइकिल में, राइट? 2 3 4 5 6 7 8. टेल मी एनी डाउट अप टू हियर? So now see what they are asking. What will be the output for SISO after 6th clock pulse? तो 6th clock pulse के बाद ये है आउटपुट. Q1 में 1 है, Q2 में 1 है, Q3 में 0 है, Q4 में 0 है, Q5 में ये है, सोन. ठीक है. 8th clock pulse में ये है, यहाँ पे ये हैश. Then they are asking how many clock pulses are required to shift MSB to the output. अब मुझे MSB को शिफ्ट करना है. 8 तक तो मेरा हो गया. अब 8th क्लॉक साइकिल में क्या मेरी MSB शिफ्ट हो रही है? नहीं हो रही. तो वी नीड 9 क्लॉक साइकिल, बिकॉज इफ आई मूव टुवर्ड्स द नेक्स्ट क्लॉक साइकिल 9th वाली, तो आगे वाला चला जाएगा, अपने घर चला जाएगा, और MSB विल बी शिफ्टेड टू द Q2. सो दिस वन विल बी हियर, राइट? So we need 9 clock cycle. तो ऐसे पूरा ये you have to draw it. Okay, now see, this is the question of K-map, 4 marks का है. A combinational logic circuit has 4 inputs, right? So now we need to draw the truth table based on that. 4 inputs means how many combination we have. That is, if we'll have 2 inputs, then 2 raised to power 2. If we'll have 3 inputs, then 3 raised by 2, and if we'll have 4 inputs, then 4 raised by 2, that is 16. So A, B, C, D, and output is denoted by F. If we'll have 16 possible combinations, then it would be 8 times 0, right? 8 times 1, like so. Then 4 times 0, 4 times 1, right? Then 2 times 0, 2 times 1, 2 times 0, 2 times 1, so on. Then 0, 1, 0, 1, 0, 1, so on. Now, the output F will be high only when 2 or more inputs are high. Okay, like see, in the first case, all are 0. So, output is low. Low means 0. In this case, second case, there is only one high input. In this case, also 0. In the third case also there is one, so there is only one here, so this is also 0. Now in the fourth case there are two cases where two ones are there, as they said 2 or more, so do hai, so it will be 1. Now understood? Now for basis on that you need to complete this table, like last वाला भी 1 आएगा, suppose वो 1 1 1 1 होगा, so you need to do the numbering 0 1 2 3 4 5 6 7 8 up to so on 15 तक जाएगा. So then you need to make a K map of 4 by 4. Like suppose it is AB, D 0 0 0 1 1 1 1 0. So 0 1 2 3, right? 4 5 6 7 8 9 10 11 12 13 14 15. So 0 number पे 0 marked it 0, 1 number पे 0 marked it 0, 2 number पे will have 0 marked it 0, 3 number पे will have 1, so marked it 1. ठीक है? और you can do it directly also. कि 0 0 है तो 0 ही रहेगा, 0 1 0 1 and 0 1, तो दो बार 1 है तो 1 आ जाएगा. ठीक है? 0 1 and 1 1, तीन 1 है 1 आ जाएगा. 0 1 1 0, दो 1 है 1 आ गया. 1 1 है 1 आ गया, दो 1 है, तीन 1 हो गया, चार 1 हो गया, दिस 1, ये सारा 1 1 आएगा. दिस इज 0, दिस इज दो 1 हो गया, देन तीन 1 हो गया, देन दो 1 हो गया. दिस इज अंडरस्टूड. So this is how we can do pairing. तो टोटल पेयरिंग कितनी होगी? 1 इज येलो 1, ग्रीन 1 2, ब्लू 1 3, पर्पल 1 4, this one 5, this one 6. So in this we'll have total 6 pairing. Name it. So it is negative, means inverting summing amplifier. This resistance will be 10 by 5, 10 by 3. Output is V naught. Feedback resistance they have given as RF. Now suppose if they have mentioned minus 5V, minus 3V1 and plus 2V3, then tell me what would be the changes in the diagram. They said draw the Zener voltage circuit. 4 marks का question. So Zener voltage circuit is, this is supply voltage, this is supply resistance, is Zener diode, this is the load resistance, that is denoted by RL. Now they said Zener diode has a breakdown voltage of 10 volt, means that they have given as 10 volt. It is supplied from a voltage source varying between 20 volt and 40 volt. So supply voltage vary from 20 volt to 40 volt. Series resistance they have given as 820 ohm. Load resistance they have given as 1 kilo ohm. They are asking the minimum and maximum Zener current. So we need to calculate IZ minimum and IZ maximum, right? So remember I told you ki whenever we'll have minimum and maximum kind of circuit, we'll use second kind of circuit. Remember I gave you the list of formulas of the Zener diode. Did you remember that? So now tell me. So we get the value of IZ minimum as 2 milliampere, right? We have used Vs as the minimum voltage. Now you can do the same procedure by using 40 volt. Then after solving it, you will get the IZ maximum. If you will take minimum voltage, then you will get minimum current. If you will take maximum voltage, then you will get maximum current, right? Silicon diode has a reverse saturation current. The formula for that it is ID is equal to I naught raised to power VD divided by eta minus 1. Okay, this minus 1 is with whole term. So basically VD is the applied voltage. Okay, and we'll have formula for V, that is temperature divided by 11600. Temperature must be in Kelvin. And eta value is fixed, that is 1 for case of germanium and it is 2 for case of silicon. Okay, so ID is the diode current, I naught is the reverse saturation current. So they have given a silicon diode, means eta is 2, has a reverse saturation current, means I naught is 12 nanoampere. 12 nanoampere means 12 into 10 raised to power minus 9 at 20 degrees Celsius. So temperature is 20 degrees Celsius, add it with 273, it will convert it into Kelvin. So ये हो गया 293 Kelvin, right? We can put the value, then we'll get V. VT है, eta है, I naught है. Now they said find the diode current when it is forward biased by 0.6 volt, means diode voltage they have given as 0.6 volt, 5 volt. So everything is given. Now we need to calculate ID. Calculate it. Now next they are asking the dynamic resistance. Dynamic resistance is RD, that is V over ID. So VD we know 0.65, ID we'll calculate it from the first case. We can substitute it here, then we'll get the value for RD.